Today I'll be going through the CHE312 bubble do calculation tutorial in Aspen. I'm using a preloaded file today, however, I will be explaining and showing my screen throughout what I'm inputting and what I'm calculating. A little background. The whole reason we do the bubble and do calculations is because it is important that we know the boundaries of our two phases and where they can be obtained. So later in this video, I will actually show you our maximum and minimum temperatures and how that relates to our boundary conditions. This will be very important, especially in piping and equipment, so that we know if it will be one of the two phases or both phases together. This is the setup for the simulation. However, I will not be always using these specific items. Another thing to point out is that the selection of the template will set default units and properties. So this will be useful in obtaining activity and fugacity coefficients. However, you want to pay attention to what you're picking. This will most likely be based on the handout given or what's in the problem statement. So just watch out for that. And so to start this, we're going to click gas processing, metric units, and gas processing of metric units. We're going to open that selected template. Starting off, you'll be given this screen. This is the component selection screen. So you'll use find to actually go through and find ethane and butane here. If I know what I'm looking for, I'll use equals right there. But if I don't exactly know what I'm looking for and it does involve ethane, I can do contains and then sort by molecular weight. There is a video linked in the Google document to maybe help explain this further. So once you have your components entered, a great way to continue the process is by clicking this next arrow, the binary interaction parameters. And even if you don't necessarily know what these numbers mean, it is important to look over them. See, it automatically puts you at this PRK, and some of these are blank still. But it's important to look at this and make sure you approve these because this is from a database. So once you leave this screen, that means you're telling Aspen that you approve it and that it's allowed to do the calculations with it. So once you've approved these values, we can move on to the simulation. So now that we've run the simulation, you'll be greeted with your main flow sheet. There is also a video on this that is linked in the Google Doc. I already have my splitter set up here. However, there is an example in the PDF and in the Google Doc, there is a YouTube video linked. And the reason why we're using a splitter is because a bubble do or flash calculation can be performed on any stream, but Aspen Plus specifically requires some unit operation to be present, and a splitter is one of the most simple unit operations we can do within Aspen. Essentially, the splitter will divide a stream but does not separate the vapor liquid composition. It will work as a placeholder to perform the calculation. However, we could use a flash drum, which would be right here under separators, and then we could use a flash too. So like I said, I've already input everything into this file, so I'll go through with you what the next arrow would be pointing out to you. So once we've got this set up, it'll ask us for an input of stream 1 or our feed. So that next arrow will prompt you to this inputs that I've already labeled here. So you can just copy this into your stream 1 or feed. And we'll start with a vapor fraction of 0. This is also known as V over F, and this stream 1 and this V over F, or vapor fraction of 0, means that it's all liquid coming into the splitter. Moving on from that, it will also prompt you, if you click the next arrow again, to create a split fraction. Here I have it set as 0.5. This is an arbitrary value for Aspen to split the stream. It doesn't split it into like half liquid, half vapor. It literally just splits the stream in half. So Aspen may prompt you to fill out stream 2 and stream 3 as well, but remember, we don't know this yet, so we'll leave it blank for now. So Aspen has successfully ran, like so. We can go to streams and view our temperature. So if you'll see, 2 and 3 are both liquid phase, and that's because our V over F was 0 entering the splitter from stream 1. So it simply just split these. And that is our bubble temperature of negative 19.79 degrees Celsius. So if we wanted to, we can go back to stream 1 and set our vapor fraction to 1. So our V over F is equal to 1, which means it's 100% vapor entering the splitter. And when we go to rerun that, going back to streams, we can see that our dew condition is 37.44 degrees Celsius. So one more time, if we actually select a V over F of 0.5, or just 0.5, there we go, we can actually see that the temperature will be between the dew and bubble conditions. And one more time, going back down to streams, our temperature will be 12.26 degrees Celsius. When you create a V over F between 0 and 1, it will be within that temperature range. So we could even go again, just to prove myself, 0.75. Rerun this, and we will get a temperature of 28.37 degrees Celsius. And again, that is because it is not completely vapor or completely liquid, it is a mix. I'd like to emphasize that the PDF will be available most likely on D2L, or there's also a Google Doc that has been worked on to provide YouTube links to the more basic Aspen aspects, like setting up your ethane and butane or setting up your flow sheet. So please check that out if you're having any issues.